of a hierarchy diagram where you have various types of hierarchies, various types of classes, really kind of a real estate uh, asset, insurable item, banking, checking account, savings account, and so on. So you could check on this later on and understand how these diagrams represent the real world. Another, which is in terms of employees in an organization. So you have employee, you have temporary employee, permanent employee, and manager is a special kind of employee. A temporary employee could be a consultant, and a manager could be a director, and you have permanent manager, or which is a permanent employee. And so what you see here is something which we have not discussed earlier, which is the case of multiple inheritance. So this is the case where one class can inherit properties from two different classes. So we can say consultant manager is a consultant and is a manager. So the consultant manager has properties of consultant as well as properties of the manager inherited in them. And oftentimes we will have situations where multiple inheritance occur. Now, multiple inheritance in actual implementation terms may have several issues, because you can see something of a structure here. Just concentrate on this part. Employee is specialized by manager and permanent employee, and then permanent manager is a specialization of manager as well as employee. So if you look at this, which is typically called a diamond in multiple inheritance, not specific to UML in general object oriented principles, you can see that in the permanent manager, you can have an employee employee record which comes through this path, the manager path, and it comes also through the permanent employee path. So if I try to write this directly in say C++, then we will have two base instances of the employee, which is certainly not what you want. So you have different techniques of handling that in terms of virtual inheritance and so on, and things get quite complicated because the diamond can happen. If you have a simple multiple inheritance where diamond cannot happen, which is usually what does not occur, because you are having a hierarchy in terms of specialization always. With the diamond, you have these issues. Therefore, usually many designers prefer not to use multiple inheritance. Use one of them which is more dominant as a inheritance, and use the other as a property of the class. So that's kind of issues that happen. So we have so far not preferred to use multiple inheritance in our design, but it actually exists, and UML standard allows multiple inheritance implicitly. And you can see that because of different issues of how you interpret diamond and so on, the standard does not provide a specific definition for what multiple inheritance would mean. It allows it. I mean, in this diagram it allows, but has not given, the standard has not given a semantics for what is employee in permanent manager. Is it taken in this path, or is it taken in this path? Is it a unique employee here, or it could have actually two different instances? Question is, what does it mean, and so on. So there are inherent questions here which UML leaves open in case, whoever wants to use it, because some people prefer to use multiple inheritance severely. It has advantages too. Then the other kind of beyond generalization, the other kind of relationship is known as dependency, where two classes has some kind of dependency or need of one another. Like you have a search controller, and you have a site search interface by which you can actually search. The interface is what comes on your browser, and you can handle with that your input data and other output. And the search controller actually instantiates or implements that interface. So we say search controller depends on the interface. Naturally, if you change the interface, the search controller has to change. So we'll say that the class search controller depends on or requires search interface. So this kind of arrows, dotted, dashed arrow with a open arrow head is the way to show dependency in between classes. So this is the second kind of relationship. The third kind is constraints that you can put, and I have shown here two kinds of constraints. One is, this is a simple relationship in association: stock purchased from vendor, right? So arrow is not shown, it is implicit from the name, and the multiplicity could be any number of stocks could be purchased from any number of vendors, including 0. But we put a constraint as a kind of annotation here. I mean, not a very structured way, but it's a kind of annotation here. We say that for stock to be purchased from the vendor should be listed in NSE, National Stock Exchange. So this is a constraint. So if a purchase is being thought of from a vendor who is not listed in NSE, so the vendor is listed only in BSE, the Bombay Stock Exchange, then this will not be a valid model, right? So these are the way you can have specific constraints or subclassing, you can say, in a way, on a class represented as a relationship. This is also very interesting, that you can have constraint between two different associations as a relationship. So we say that regulated water cooler, or say even our car air condition. So a car air condition can either act for cooling, make your car cold, or it could act as a heater, make your car heated, depending on the weather you are in. So in case of regulated water cooler, if we say heater activates regulated water cooler, the cooler activates regulated water cooler, which are simple associations, but only one of them can happen at a time. So we say they are constrained by a relationship of XOR, exclusive OR, that either heater activates or the cooler activates, or none of them can activate, but both of them cannot activate, right? So these are the kind of constraints you can have in your relationship. So we see that in terms of UML classes, we can have generalization, we can have dependency, and we can have constraints besides the different types of associations that we have seen. So this is the typical way to represent class diagram. So this we have seen before. Now we have seen all different definitions of class diagram elements, so you can see them better. You have an abstract class here with a italicized name. You have a generalization of the book item, which is a stereotyped class. You have account here, which is patron has account, so it's a weak aggregation here. Library has accounts, again weak aggregation or aggregation here. Library has book items, aggregation here. And catalog is associated with the book items in terms of catalog recording the book items as an association, and the multiplicities are shown everywhere. And library has a catalog because that's a component of the library. And you have other relationships of author wrote a book, account borrowed certain up to a certain number of book items, or reserved a certain number of book items. And you have interface. We have just seen the dependency relationship. So these are interface realizations. These are dependency relationships. These are dependency relationships that you can have here. Right. So I will leave this for you to understand. You already have the leave management system specification, so you can validate that. This is kind of the use case diagram which we have already seen of different actors and use cases. And we will translate this now into the class diagram. So if we go back, then we will see abstract classes that are required for representing these actors and also required for representing the leave which they deal with. Right. So abstract classes, you'll have to identify the properties and operations and the relationships resulting in the final class diagram. So these are the two abstract classes, employee and leave. We have seen this before. These are the properties. I mean, we are not getting into a specific design aspect of LMS, but more in example terms. So you could do a better scrutiny to decide if you want all of them in the public or you want some of them in private or protected specifically. These are the operations added onto the employee and the leave. You can record attendance, request leave, cancel leave, avail leave, and so on and so forth. This is at the level of the abstract class. And then these are the associations you have between different classes, a specialization hierarchy, then different associations of what the use cases translate to. So an executive can request for a leave, or executive reports to the lead can request for a leave, manager can approve a leave, and so on. So those use cases are now getting translated in terms of these associations, which will invoke the corresponding operations in the target classes. Right? Then you have a weak aggregation of leave into the leave records, and similarly employees into the employee record that you have. So this is one possible way of doing generalization, hierarchy of leave. So this is a abstract leave is a base class. Then you can make these are the leave classes, right? These are different types of leave: sick leave, maternity leave, parental leave, casual leave, earned leave. Uh, mm, if this is parental leave, yeah, this is parental leave. This is, I'm forgetting what is the name. Then LWP, leave without pay, unauthorized leave, and so on. So you have created certain intermediate abstract classes by factoring out the common properties like uh, sick leave, maternity leave, and parental leave all need certification. So you club them together to inherit from a certified leave abstraction. Whereas there are leave like the casual leave or earned leave, which does not need certification. So these are uncertified ones. And both of them specialize from personal paid leaves. That is, these are the leaves for which you get paid. Then there are some leaves which must be approved a priori, and some for which you can have a post facto approval. So you are creating an abstraction based on that concept that every abstraction is one idea. Remember that, ignoring everything else. So the post facto is sick leave is post facto. Obviously, you cannot plan your sickness. Similarly, casual leave is post facto. Then some leaves which cannot be clubbed with others. Casual leave cannot be clubbed with others. And then all these finally again get into the leave abstraction. So this is kind of the generalization hierarchy. I mean, this is again these are design issues. So what I'm trying to show is that you how you can represent these concepts in UML. The actual exact design is your choice, and it will vary from one person to the other because how you visualize, and there could be trade-offs between different kinds of hierarchies that you could build. Using this hierarchy, you could kind of make a LMS class diagram. There's a partial part of the diagram which is shown here. So on this side, you see the employee hierarchy, which shows some of the properties of the abstract employee class inherited by others, and they will have more properties here. and the reports to association being shown here. You have the leave hierarchy we have just discussed in here. So these are the two hierarchies that are involved from the two abstract classes that we had identified. And then you have different kinds of aggregations and associations, like you have employee requests leave, employee approves leave because lead or manager can approve leave. A an employee consults a doctor for certification. Doctor issues certificate. Documentation has a certificate. It contains a certificate in all the kind of things you do. Leave has documentation, which is a weak aggregation. Leave has leave record has a leave, so this is a collection of leave and so on. Of course there'll be more. So this is just to show you a kind of a sample overview of how the overall class diagram might look like, and that is kind of a very often 1 or 2 page summarization of your long descriptive English language specification with ambiguity in an unambiguous form, in the way you want to represent and interpret your system. Okay, so that brings us to the end of class diagram. Before I move on further, let me just ask check if there is any question on this part. Otherwise I'll continue on the next diagram. Any question, friends? No questions. Great. Attendance is low today. There must be some test later on for some subject. Okay, let us get back, and we are in module 29. So we have talked about the first level, very high level behavioral diagram in terms of use case diagram in UML, and we have talked about the structural diagram, the most important structural diagram, the class diagram in UML as well. Now, class diagram you knew pretty much. Use case diagram was more intuitive. Now, I'll talk about a different behavioral diagram which is used to depict the temporal and execution time behavior of the system. This is called a sequence diagram. As the name suggests, it is the kind of sequence of events that will happen. So the sequence diagram is conceptually modeled on client server. So which say that a behavior is a service provided by an object of a class. What does that mean in our concrete terms? It means the interface that the object supports, which anyone else can send a message to, or in simple single machine C++ implementation, Java implementation terms, it could be just invoking a method. But it could be in general sending a message, because you could have really a message passing system, or you could have an implementation which is distributed among different servers. So one object, the requesting object, could be in one machine, and the requested object could be in a different machine. So you send this service request by sending a message. At the lowest level, it boils down to the invocation of an operation or a method call. So in the client server view, client requests for service, server provides service, and there is a contract between the client and the server which ensures correctness. What is that contract? The contract is an interface specification. So the contract says that by the contract, the object supporting the service guarantees that if a service is requested according to the interface correctly, then the service will be provided. Similarly, the client has to ensure that when the client is requesting for the service, that client must request for it in a correct manner, right? So that is viewed as a contract between the client and the server. So the sequence diagram, as we have seen, occurs in the analysis phase after the requirements phase, where you have identified the requirements and made the use case and classes. So it is one of the behavioral models that it has, probably the one of the most important behavioral diagram that you have. And then it goes on to stay in the design phase as a part of the behavioral model. When you might detail it out further as you are detailing out other behavioral models as well as the structural models, right? So what it is, it's a most common kind of interaction diagram, and it focuses on message interchange between a number of lifelines. Lifeline is the key concept of the sequence diagram. Lifeline is, if you want to draw the closest parallel, it's like the lifetime of an object in the system. We have talked a lot about the lifetime of an object, right? Now, like in terms of the lifetime of an object, we say that this is that instance where the object gets created. Then there is a period of time for which the object is alive and it is providing service, it is being used and so on. And then at a certain point, the object is destructed, killed out. So it is a similar kind of thing that for every object that dynamically happens in the system, you have an associated lifeline to denote that. And during the on that lifeline, the object could receive messages from other objects and service them, or the object for servicing the request it has got, it could actually issue other messages to other objects in the on the lifeline and get those serviced so that it can provide the service that it has been asked for. So messages form a key part of the diagram besides the lifeline. And then there are interaction fragments. These are kind of time intervals during which different kind of interactions happen. So one is a lifeline when the object, the entity is there in your system. One are messages that are exchanged between different objects, different entities. And the third is the interaction fragment, is a time interval during which certain kind of interaction are happening. So these three together forms a sequence diagram. Right? So lifeline is an element which represents an individual participation in the interaction. And a lifeline represents only one interacting entity, right? It is only one. So if you are referring to a connectable element which is multi-valued, which has multiplicity more than one, in simple terms, if it's an array of objects, then the lifeline may have an expression or a selector which say which of these particular multi-valued connectable element is actually represented by this lifeline. The entire array of objects cannot be represented by a lifeline. It has to be an individual participant. Right? So a lifeline is shown using a symbol that consists of a rectangle forming the head of the lifeline and a vertical line, which in some cases may be dashed out. We'll see why. And that represents the lifetime of the participant. Right? As I said, it's a kind of an object lifetime. The information that identifies the lifeline is depicted as you give the object name, which is, as we'll see, is optional. You have a selector within square brackets, which is also optional. And then you have a class name, which specifies the class from which this particular object comes. Right? So the lifeline will typically look something like this. So it's a data colon stock. Let me go back one slide on slide 8. Note that there is a colon separator between the object and the class. So data colon stock tells you that it is the lifeline of data object from the stock class. So you know the details, the behavior from the stock class, and this is an instance of data which is represented, the time goes forward as you go down by this line. This is another example of a lifeline where the object has not been specified. So it is an anonymous lifeline of class user. So you're saying there is some object of class user, and this is a lifeline for it. This is a third case of possibility where you have a selector. So small x is a collection of objects of class X type, and you are selecting the kth of that. So k is the selector here. So in an array, you are selecting possibly the third object or the seventh object or the 29th object and so on. And for that object, this is the lifeline, right? So there's a basic depiction of the lifeline in the sequence diagram in UML. So if we look at the leave management system, these could be the possible, elements: E1 employee, E2 employee, E1 leave, E2 leave. And the major interaction activity could be request leave, approve leave, which require interaction between the two classes, employee and the leave. Right? We will come to examples. Now, so we have talked about the lifeline. Next, let us talk about the messages. Now, in terms of messages, obviously a message is between two objects, between two lifelines, right? Now there are two major types of messages in the sequence diagram. One is messages by action type. I mean, what kind of action you want to take reflects either, which is the most common, either an operation call on start of execution or sending and receiving of signal and so on. These are the messages of action type. And then there are messages by presence of events, that this event has happened, so it is assumed to be a message, right? So let's see what these are in detail. We will detail out. So first, talking about messages by action type. Now, the various types of messages by action type are these. One is, it could be a synchronous call, or it could be an asynchronous call, or signal. It could be create, it could be delete, it could be reply or response, right? So synchronous call represents an operation call. You send the message, and after sending the message, the sender suspends its own execution and waits for the response. So there is a web client object which is sending a search request to online bookshop. Right? Web client is some PHP, some JavaScript running on your browser, and you have the backend online bookshop. So you send a search message. So this is a lifeline. This is another lifeline. These rectangles residing on the lifeline are instances of execution. We'll see what it means. So some request is being processed here. Now, as a part of that, the web client raises a message search on online bookshop object, anonymous. And the servicing of that message starts. So you can see that this starts this rectangular block. And look at that way the message is depicted. Besides the name search, it has an arrowhead, which is a triangle, which is filled. If that happens, this is a synchronous call, which means that once the web client has sent this message to online bookshop object, the bookshop object is servicing until it ends and gives you a response back that, okay, I'm done. This web client object will continue to do nothing, right? It will stay at that point itself. Whereas you have an asynchronous call where you send message and proceed immediately without waiting for return value. So there's a service and task. You say, okay, this needs to be done. So you have prepared a list of records, and you send it to the spooler of the printer. You send that, and after having sent that, you don't need to wait for that printing task to be completed before you do other things. So you send an asynchronous call here. So you say the service object is asking the task object that you start this task, right? So the MIS object, the management information system object, is sending a request to message to the printer object that you start printing. And you can see that the difference is in the arrowhead. It's just open to angular arrows. And when you do this start, after that, the service object does not wait here. It continues as it is doing. It is send the message, and then the task object will take care of it. So open arrowhead. So these are the two most common type of messages by action type. The others, of course, there has to be, I mean, if you have lifeline, if you have objects, you need to have the beginning of a lifetime, the construction, you need to have the completion of a lifetime, the destruction. So you need similar initiation and termination of lifeline. So you can send a create message, which will start a lifeline. So online bookshop sends a create message to account object. So which it means is account object actually was not participating in the system at this point. And you can see that it is an asynchronous one, and it is dashed, which indicates that it is a create message request. So this is where the lifeline of the anonymous account object will start. Similarly, you can have a delete message to terminate the lifeline. You can say destroy, and you're sending this typically as a synchronous call, because you want to see whether it has happened successfully or not. And it is depicted on the lifeline by putting a cross on this vertical line, beyond which the line will not exist. So the lifeline of account object has ended. So this is the delete message which will typically have. Finally, certainly you are sending requests. So how do you know whether the request has been serviced? For synchronous call, you are waiting for that response. Even for an asynchronous call, you need to know if the service happened successfully or it did not happen successfully. So there is a reply message, which is kind of looks similar to the create message, which on completion of the service that was requested is sent back from the requested object to the requesting object. So this is a reply message. So if it is a situation of a synchronous call like this, so in between this time, the web client object was not doing anything. Only the time has advanced, but in terms of execution, nothing has advanced, right? And the online bookshop object was servicing this. So we see that by action type, we have 5 typical messages, which are synchronous call, asynchronous call, create message, delete message, and reply message. Right? The other kind of messages are in terms of messages by presence of events. So typically, most messages will be complete message, where there is the pair of, the complete message trace, roundabout trace include the send event as well as the received event. Both send and receive events are present. But there could be cases where one of these or both of these are missing, right? So there are 4 types of messages by presence event. When one is a lost event, that is the send event is there, but the receive event is not there. Who received is not known. Or there is a found message, that a message is received but not known from whom. And there could be unknown message, which is, by default, everything is an unknown message where both send and receive are absent, but that should not appear in your system. This is just conceptually there. Again, the zero of the system, as we say. So a lost message is depicted like this. So web client sends a search, does not know to whom, and you have this filled, circle. So this shows that you have the send message, you know where the sending where the sending event is known, but the receiving event, who has received, is not known. Similarly, found message is where you do not know the sender, but this has been received by the online bookshop. So whenever you have to depict such situation that, okay, I'm talking about the online bookshop, or maybe oftentimes these are used also for, kind of kind of factoring and, management of abstraction. For example, online bookshop might get search requests from various multiple objects, various multiple lifelines, and then you want to detail out what does the online bookshop do on getting that, what are the other services it use and process that, and how does it find out, and so on. So you do not want to clutter that part of the sequence diagram on the with the information of the receiving side. There could be multiple different uh, lifelines from where it is coming. So you can depict that by saying, okay, this is an anonymous or unknown sender. The sending event is not known. Later on, it can be. Similarly, various of these, clients could be sending requests to multiple, search agencies. I want to do a search through Google at the same time, through Yahoo at the same time, through Bingo, and so on. So I depict that, but I want to search using some, lifeline which can support my request, but I do not know what that lifeline is, so I can depict it in terms of lost message. So these are the two different types of messages. So by presence of event, these are the main two. So here, taking from this UML 2.5, I show annotated sequence diagram. This is a sequence diagram for submitting a comment. And you are submitting a comment on a window. So you have a window object. So this is how typically these diagrams are drawn. You have a rectangle and on the corner with you write what this I mean, often this is what you are trying to relate to is this sequence diagram relates to the use case submit comment. Right? So you are giving that name so that you can relate. This is the use case for which I've done this. So there are four different lifelines, as you can see, these three and this one, which is a spatial kind of iconic representation of servlets, so to say. So there are four lifelines, vertical lines going. There's a anonymous window object, so where you send the validate request, right? So you have to come there and get validated. So it's a synchronous message. So you are trying to do the whole validation of the command. So you come to this window, it starts processing, in turn it sends out. So time is progressing. So time is progressing downwards and the messages are flowing from left to right. This is a sequencing happening. So it's completely temporal. We still do not know spatially what's happening. We'll see that later on. So this in turn sends out a request for validate to a JavaScript object of the comments class. Right? So you can see that both are synchronous. So whoever had requested this validate at the gate is waiting. Similarly, on this particular execution on the window object is waiting. And you do the you start processing the validate for the comments by the comments object, and now you create a new lifeline on the as a proxy on the Ajax to do this task. So you create this lifeline. This is a creation. This is done, and create typically, as you can see, you must have noticed that it is a asynchronous call. It is an asynchronous message. It's a non-blocking one, right? Because you have to, after creation, you have to do something. So after a while, then you send the AJAX, the asynchronous message again to this proxy object to do the task. It does that task and it calls back in terms of the original window. It calls back to the original window that this is what has happened. Or it could actually do a certain kind of successful processing. So you finish the validation, and you know that this kind of a callback will happen within a certain time duration. So this is a duration constraint that you have, and these are the reply messages which are taking you back here. And if you have had an error in terms of the servlet in turn, then you will handle the errors here. So not the details of the system, I'm just trying to show the use of different of this sequence diagram elements in a realistic sequence diagram. This is another, which is a very common way to handle login in a e-commerce portal or some portal, say. So you have again 4 lifelines. One is an actor, who is a person. So lifeline for that. Then the person, it requests a message, a service for login with parameters user ID and password. That's what we typically do. So it goes to the GUI, which is the login object, and it is a blocking call. It's a synchronous call because unless the login has been validated, there's no point going forward. So that in turn requests the session manager in terms of verifying this login, whether the session is active and whether the user is already logged in and so on. So it gets that verify login with the user ID password. It is again a synchronous call. Then it actually checks whether the person is a valid customer. So it requests to the customer object to get user given the user ID, checking whether the given user ID is a valid one here. So this is also a synchronous call, and then there's a response after a while with the user details. So it's got the user details now in the session manager. Now it sends a self message. The self messaging is quite possible. So you can see overlapped execution. So this is like a function call. You're stacking the function call. So you do a verify login call here with the user details, and then there could be 2 possibilities. So that is what you show on the timeline. If the customer is invalid, then you send back a reply message that login has failed. Otherwise, you send back a reply message where login is successful. Remember that this is time progressing, but this is not in the time scale. That is, there is a gap here. That does not mean that there is time elapsed. It's just showing that this is a sequence. And obviously, on this validation, either the failure can happen or the success can happen. So whatever happens at the same time instance, and that's when it come back. But we are just showing the progression of time. Whenever we will need to talk about the real time, we will put that as a constraint on this, as we saw in the last example. So based on that, if the login is successful, then it goes back and logged in. Otherwise, it will give a message here again, not depicted in this diagram, that login could not be done. Right. So this is the login that has happened. Now, once the login has happened, then this shows how the order is being placed. A little bit more complicated, but an excellent example in my feeling to understand the sequence diagram. So you're the person who is trying to buy something, so it does a select on the product. Now, naturally, it needs the response from the select. So then it goes to the session manager with the product that has been selected. Then it does a add cart item. So this is a shopping cart lifeline where you are adding that item. All of you must have done this oftentimes. So it says, so a selected product is given to the session manager who requests shopping cart to add it. So now the shopping cart has to create a new shopping cart item, right? So this sends a create message. This particular diagram does not follow the 2.5 UML 2.5 notation. By UML 2.5 notation, this should have been dashed arrow with a open head. So the cart item is created, now created, and it gets back to the shopping cart. So shopping cart now has a cart item that it can actually add. So it does a self messaging to add cart item, does a function call. Then it does another to put the calculate the price, right? So it progresses like that. So with this, again the return replies are not shown explicitly here. So this is the part on top which is adding the cart item, and the dashed ones are lines show that that the sequence is progressing, but there's nothing specifically that you want to detail. Then at a later point of time, the person, the customer tries to do a checkout of the order. So he sends a checkout message to the session, to the shopping cart, because cart now has items. So on that, this is a synchronous call. Then that it sends an update profile. It already has the customer information. It could come as a parameter in the checkout also. So to the customer object, it sends this request and gets the updated profile. For example, it could be the kind of the status of the customer. Are you a prime customer of Amazon, or what is the address? What is your payment method, and so on. All this information you get from this profile. And then the shopping cart calculates the total price by doing a self message, calculate price. And then once that has been done, it places the order, right? So this will be a new, actually, a placing an order. So in the order object, a execution starts, or the order is prepared, and then an order confirmation reply is sent back to the person. So this could be a logical flow in terms of the sequence of events that happen in terms of placing an order in an e-commerce system. I'll leave this for you to understand. This was I mean, now it's far more complicated. Used to be the way for Facebook authentication that I mean, one way that Facebook used to authenticate its users earlier. The remaining part includes the illustration from the leave management system. So you can, taking these, you can form the sequence diagram for the request leave from employee, creating a new leave, checking the validity of the leave, and returning if the leave request is valid. Similarly for the approved leave. We are out of time now, so I will discuss those and some more details of nuances. What we have primarily discussed in terms of sequence diagram are lifelines and messages of action type, and messages of the presence of event types, and have seen them in the examples. So what is remaining to look at is the interaction fragments. I mean, what are the different kinds of interactions that can happen on these messages? Some we have already seen, that it's a start of an execution, end of an execution, or the execution itself, the trace. We'll see more of that in the next class next week. Let me go back and check if you have any questions. Any questions, friends? Are you awake? I hope so.
Yes, sir.
Okay. That was sweet. Okay. So I hope this is understandable. Please try to study the sequence diagram well, besides the use case and class diagram, because that's the third diagram that we are going to ask for in your assignment 4, which goes out very soon. And for the booking case, it will be sequence diagram will not be very complex. It will be quite simple, because we are not taking case of order and all that, but there'll be validations and all those which you will have to depict in your sequence diagram and so show the interaction between variety of objects that are taking part in your system design. Okay, then if there are not more questions, let me stop here, uh, and have a nice day and a good weekend. And we meet again on next Wednesday. Thank you. Bye.